Hello everyone, my name is Fernando Teixeira and I'm a senior instructor at AWS currently teaching at the AWS Cloud Institute. Today we're going to look at some practical Lambda on a serverless cloud application. Today in my background I figured I would go local, so I have the Shogun Mountains in New York. Let's begin with the prerequisites. You're going to need an AWS account, AWS programming credentials, and the AWS SDK for Python. I got you covered with those three because I have a video that I'm going to link in the description. But you're also going to need a little basic understanding of IAM, but honestly that's not too tough and you're not going to need to go very deep for this video. In my video series, I'm building a simple trip planning application, so the Lambda functions we'll be looking at are used for this application. Let's take a look at the application. I'm going to be basically storing trips, and you can create them and look at old ones, but more important, you can create itinerary for those trips based on your personal preferences, and I'm going to use AI to generate that detailed itinerary. The architecture for this I actually have described in a separate video, and I'll give you the link for that in the description. But in a nutshell, I have a React UI that then calls API gateway APIs, and all of those APIs are supported by Lambda functions. The Lambda functions are going to have access to the database and for the AI stuff to Bedrock. For this particular video, I'm going to be focusing on the database functions and more specifically the trip get, the one that gets one particular item from the database. Nothing specific about that one, but I figured that was intuitive. You get one trip out of the database. Before we get to the code, I'm going to start with a super quick introduction of Lambda. Okay, let's roll in a whiteboard to talk about the basics of Lambda. First thing I like to look at is that the overall Lambda function is different than your Lambda code. Developers like to think that the code is everything, but no, there is more than the Lambda function overall gives you. For instance, the runtime that your code runs on top of, such as Python or Node.js or Java and a bunch of other ones, yeah, the Lambda function service is going to give you that. Then there's also triggers. Triggers are a wonderful thing because your code may have to talk to a bunch of AWS services like S3, DynamoDB, SQS, and SNS, and Kinesis, and so on and so forth. And triggers are going to allow you to do that. It's a couple different ways that can happen. In some cases, services like S3 or SNS, they're going to push events to you. In other cases, the trigger is actually going to go out there and pull events like in DynamoDB or SQS and a few others. Regardless of whether you're doing a push and a pull, well, Lambda is going to have an internal queue. And as the events come in, the events get forwarded to my Lambda function over here. My Lambda function code actually just kind of wakes up and goes, oh, I got an event. And if more events come in at the same time, yeah, it's going to spawn off 1, 2, as many as you configure that can be running at the same time. That's your concurrency. And now I get to the point that I'm going to write my code. Well, maybe I want to use Bedrock to do some AI. So easy peasy. I'm just going to go in my code and make the call to Bedrock, right? Well, not quite, because I may not have permission to do that, because in AWS, you don't call anything without permissions. So how do I get my permissions? Well, Lambda has a lot of support for IAM. Specifically for this case, I want to make sure I have an execution role. My execution role is basically the hat in IAM that gives me the permissions that I need. So yeah, my Lambda function is going to be wearing that hat. And yeah, with that hat, that has the Bedrock permissions. And yes, beautiful. Now I can make that Bedrock call. But that's not the only IAM thing. Let's say, for instance, that I have an API gateway over here calling my Lambda function. That's a very common stack, and in fact, the one that I use in my example. Well, API gateway may not be able to call the Lambda function because Lambda also supports resource policies. That's how in IAM I can say, hey, I want to control who calls me. So I need to be able to, in my resource policy, say, yeah, that API gateway is okay. And sure enough, I can get the call made. And last but not least, let's not forget, particularly from an architecture perspective, that my Lambda function can only run for a maximum of 15 minutes. That means you have to pick and choose the cases for Lambda. Microservices are a pretty good one, and just some quick utilities. So we're going to do this hands-on step by step. First, we're going to create that IAM role that I'm going to need with the permissions for my Lambda function. Then I'm going to create the Lambda function itself. Then I'm going to enter the code for my Lambda function. Then we're going to deploy the Lambda function. We're going to test it locally. Then I'm going to talk about how I can publish multiple versions of the Lambda function and then create aliases for those different Lambda functions. So let's go. I'm starting over here in the IAM dashboard, and I'm going to select roles. And I'm going to create a role over here. My role is going to be for a specific AWS service, in this case, obviously, Lambda. And I'm going to continue. Now I get to select the policies that I may want to add here. I always like to use AWS managed policies as much as I can. So in this case, I'm going to start with the Lambda basic. See, there is a Lambda basic execution role that gives me, well, as the name implies, the basic things that any Lambda function is going to need. If I expand, you can see it's a bunch of things about being able to write things to a log, because we're going to need to use logs to verify if our application worked well or not. In this specific case, I know I'm going to be using DynamoDB, so I'm going to need a DynamoDB policy. I have a lot of options. I'm going to pick the read-only one because remember, least level of permissions. I'm only going to read out of the database for this particular function, so I might as well use the read-only one. So I'm going to check this one. If I expand this, yeah, you can see there's a ton of things over here that are in their policy. But remember, that's the nice things about the AWS managed policies. I am not gonna split hairs over, well, do I need all of that? Yes, somebody who is a total SME on this already decided that this is what you need for a typical read-only policy. So why would I not use that? So I'm gonna take that. I need to give that role a name. I'm gonna call this my Lambda DynamoDB read. I can leave the standard description over here. I'll take all of the other defaults and I'm gonna create the role. So now that role is ready, Lambda DynamoDB read, and you're gonna see me using that next when I create my Lambda function. Okay, let's go and create our Lambda function. I'm on the Lambda dashboard. I'm gonna click on create function. Then I'm gonna enter my Lambda function name. It's gonna be trip get. I'm gonna add demo to it because my original trip get is already written. I'm going to select my runtime. As you can see, Lambda supports a whole bunch of the popular ones out there, but I've been doing my entire series in Python, so I'm going to use Python over here. The execution role, that's the one that we talked about. That's a very important hat that my Lambda function is going to need to wear. I'm going to use the one that I just created. So that was, I can just start typing Dynamo. That should give me the ones. Yeah, I have a few different ones. Lambda DynamoDB read, that's the one I just created. Now I just click on create function to create my function. Well, let me close this intro screen over here. And I can start entering my code. Now I will be using the default IDE, but of course Lambda does support with plugins a number of the popular IDEs out there. I will be writing database code, so let me quickly show you the database I'm going to be using. The table I'm using is Travel Planner Trips. Now I have a whole separate video that discusses the design of this table, and it shows all the code that I'm going to be using here today. So I'm not going to get super low level on that. But for the purposes of our test here, we do need to understand that for this table that has a list of trips, you can kind of see it over here. The primary key is the partition key user ID and the sort key trip ID. So for instance, my cat Finn over here is going to be taking a trip to Rio. And my trip ID is concatenation of my start date of the trip and the trip location. Back on my code tab, let me close this little confirmation that I created my Lambda function. I get this default implementation when I create the Lambda function, but obviously I'm gonna put my own code. I've already created this code, as I mentioned. I have all of the DynamoDB code already written in a video that I am gonna share with you. So I'm just gonna copy paste piece by piece over here. Okay, let me copy the first piece. As it is with any Python piece of code, I start by importing the libraries that I need. The standard environment for Python in Lambda will give you most of the standard Python libraries. If you need additional things that are not standard Python libraries, you're just gonna have to add it as a Lambda layer, which is something we don't discuss over here. Probably the most important one to notice over here is Bodo 3, the Python SDK for AWS. Next, I'm just adding some login libraries because, yeah, any good developer has to do some good logging because not everything always works the right way, and you're gonna need your login to troubleshoot stuff. I'm gonna show you where to look for that a little later. Then, very important, I'm gonna include my resource client for DynamoDB because I prefer the resource client in most cases. It gives me a more easier interpretation of the JSON. And one more setup step, I'm not going to hard code my table name. I'm going to use an environment variable for my table name using the standard Python OS library. It's good because if you want to switch your table from a test environment to a development environment table, it's much better not to have your table name hard-coded in there. Now I'm going to enter my standard handler function. Lambda handler is the standard name that we get by default, but I'll show you later that you can change if you feel like you have to. And I'm going to add a logging statement because I always like to log my input event so I know right off the bat what came into my function. Next, I'm going to get my input data. Now recall my application is a web-based application, so my input data, the user ID and the trip ID are gonna come on a URL and a query string. Query string, for those who don't remember, are the name value pairs that you get after the question mark on a URL. And they're gonna get passed to me directly through an API gateway on those query string parameters over here. So now I'll have the user ID and the trip ID that I'm gonna need to retrieve my trip information. I'm going to drop my database code in here. I'm putting that inside a try block because in case I have an expected response from DynamoDB, I want to be able to handle that gracefully. I'm not going to get into a lot of details here because I did cover that in a separate video. But as you can see, I'm doing a get item call and I'm using that user ID and trip ID that were passed to me on the query string to retrieve the database response over here. Now I just need to prepare and return my Lambda function response. Remember, in my case, I'm using this Lambda function for a REST API, so I am building an HTTP response. It's a success, so it's going to be a 200. For the body of my response, I'm going to take that response that I got from the database over here, and I'm going to use the standard JSON library in Python to convert that to a string. And then once I'm all done, I just return that response over here, and that's going to go back to my API gateway that is calling this Lambda function. Last but not least, I'm going to catch any exceptions I get from DynamoDB, log a suitable error message, and return a suitable error code on HTTP for my API gateway. We're ready to deploy now. Before I do that, let me show you a couple of things. First of all, I had mentioned that there is a place over here where you can change the name of the Lambda handler function. I don't see any particular need for it in most cases. Also very important, particularly in this case, remember we are using an environment variable for the table name. So I have to go over here to the configuration tab. In there, I'm going to select the environment variables. And I need to add an environment variable for my table. That variable name is going to be trips table, because that's the value that I tried to read before. And the value for it is going to be travel planner trips, because that's a DynamoDB table that we looked at just earlier. Now we can go back over here to the code because we are ready to deploy. Okay, let me just scroll down here and click deploy. And now my Lambda function is deployed and ready to be tested and used. Let's begin by doing a test. Since this is the first time that I'm testing this function, I'm going to go over here to the test tab. I need to create an event to test, but here's the beautiful thing. Lambda knows a lot of the types of inputs that we normally use. So in this case, I know I'm going to be doing a API, so I can use a template over here for an API gateway, HTTP API. So that's going to be the type of request that I'm normally going to get. Now, I do need a specific query parameter because they give me a query string parameter that is a default over here. Yeah, that's not going to work for me. So I need something that would actually match my application. So I looked at my database and I have that user ID and trip ID that my code is looking for. And I pick valid values that are in my database. Now, I want to give this guy a real name because I'm going to be able to reuse this event. So I'm going to call it get trip. I'm going to save this event so I can reuse it later. And now I'm ready to test. So I just click the test button. That's going to simulate an actual call to this Lambda function. Over here, I can expand and look at the details. And I can see, yep, looks like I retrieved the data. Yeah, there's a little trip over here for Finn, start date, he's going, end date. And of course, if I knew my data, that would make a little more sense. Now, if there are some errors, I can look over here in the log itself. They give me like a little piece of the log. But if I want more detail, I can go, there's a little link over here that I can go to the logs. But let's look at how you normally would go in other situations. If you want to check the log for a Lambda function, you can go to the Monitor tab. Then over here on top, you can look for View CloudWatch Logs. And the nice thing about this is it's going to open CloudWatch exactly on the spot where your Lambda function logs are. So boom, it already put me in the right group. Hey, I can see there's a message over here. So if I click on that, Yeah, here are all the logs for my application. If I click on one of those, I can see the event response that I got back. Yeah, so this is what I sent back. If you look back at our code, that corresponds to this message logged over here. Okay, so now I'm ready. I'm good to go. I can go over here and start providing this ARN here for my users of my Lambda function. Is that good? Well, yeah. But other than early development, folks, that's not the best practice, because the problem now is if I give this ARN to my clients, even internal clients, anytime I make a change to my Lambda function, they're going to get impacted. And God forbid I actually make a mistake, there's a little bug temporarily, yeah, they're going to get directly impacted. So the best practice is to use versions and aliases over here. So let me start with versions. What I need to do is once I have something working like this, I create a version for that. So I'm going to publish a new version. It's good to give a name like original version. Publish. And now I have my version 1 of my application. Now, if you can see that it got a little :1 at the end. Yeah, I don't care that it's only a small change on the ARN. Anything different on that string over here makes it a different version. If I go over here to the code for this one, yeah, I can see the code for this version, but I can't change it. So if I go over here in any place and I'm gonna put my mouse over here, dang, 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 dang. Yeah, the noise you're hearing is me trying to enter something and it's not working. Why? Because it's frozen. That version 1, my original version, I can't alter that anymore. So that is what I would provide to my end users and my production team. So that's good. Now let's say I want to make a change. Well, I have to go back to my development version over here. Let me think of a simple change I can make. Let's say, for instance, that after I got my database response, I wanted to log a message. Right after I get the response, I'm going to put just a log message. Well, I can deploy this. And yes, and after I deploy this, I can do some initial testing. I can do some initial unit testing like I did before. But before I give this for my test team to test it, yeah, I better create a new version. So if I'm going to go over to the top again, click versions, publish a new version. Let's give it a name, extra log version. And now I have a version 2. And like I said, folks, I am going to give this to my test team, right? Because you wouldn't put this straight into production. You have the test team testing this. And then once it was good and ready, my test team approved, well, then I could actually tell my production team, hey, use that version 2. Now, that's good. That's great. But we can do a little better. Because one of the problems with just keep changing those version numbers is, yeah, now every time it changes, as I mentioned, I have to tell my production team or tell my test team, hey, test this version, test this other version for production. So the actual even better way of doing that is to use aliases. So if I go back to my base version over here again, what I can do is that I can create an alias. So I go and I click create alias and I say, okay, I'm going to have a prod version for my production team. And I get to say, well, my prod version is version 1. So my production team is currently using that, and I save that. And now you can see that I get an ARN over here with the prod at the end. Now that one, I don't even get to see the code because that can keep changing. I can keep pointing to a different place every time, but my ARN prod, that remains consistent. My production team can just plop that in the configuration files. Likewise, I can go back over here and do another alias for my test team. Test, and I'm going to say version 2 this time, and my test team is testing now the test version. And when my testing, when this version is correct, and okay, now version 2 is good to go, my test team has approved that, yeah, all I need to do is I don't need to bug the people who are actually working on production. I just need to then realign what that alias is. I can go to the alias, I can click on the prod alias, and I can say, well, my test team said the version 2 is good now. So go over here and rearrange that to version 2. And folks, here's the most important part. I'm doing this by clicking, clicking, clicking. But in the real world, that combination of aliases and versions are what make DevOps possible for Lambda. So all of those reassignments that I did by hand, yeah, that actually happens using scripts, using AWS services like code pipeline and code build, using SAM, and frankly, using even your own DevOps tools. but versions and aliases is what makes them possible. And that's all I got for Lambda today. Don't forget to check out the other videos I have out there and keep looking for the new ones. The next one I'm going to do is going to be using Lambda to make a Bedrock call to add the AI portion of this application. Thank you.